In this question, we are being asked the oxidation state of bromine in different compounds. The first compound is strontium with 2 bromines. So there are 2 elements, and I see that the charge must add up to 0 since there is no charge on this compound. If I look at the rules, I see that group 3 says that group 2A metals are +2. That would be strontium, so strontium is a +2. Algebraically, what goes into the blank is -2. But remember, there are 2 bromines, so I need to spread the -2 charge over 2 bromines, so that will give me an oxidation state of -1 for each bromine. In the next question, we have 3 elements, lithium, bromine, and oxygen, all adding up to 0. Lithium would be covered in Rule 3, which says it will be +1. Oxygen will be covered in Rule 5, which says that each oxygen is a -2. So since there are 3 of them, that would be -6. We can see that algebraically, +5 belongs in the blank, and when we divide that by 1 for our 1 bromine, we are still left at +5. I tidied up there a moment so we can go to the next row, which deals with Br2. Br2 is the elemental form of bromine, so Rule 1 applies. Each bromine has an oxidation state of 0. For D, we have bromine plus fluorine equals 0. In this case, Rule 2 is going to apply for the fluorine, -1. The only bromine is a +1. Remember, you do need to apply the rules in order, so the rule for fluorine takes precedent over Rule 6 dealing with halogens. For the last one, we have bromine and oxygen, and this time the compound has a charge of -1. So remember that we do have to add up to the charge on the compound. Each oxygen is going to be -2, so 2 of those will be -4. Algebraically, what goes in the blank is +3. The 1 bromine will be +3. The last question asks us, in which compounds is the oxidation state of bromine a positive value and why? Well, if we look at where the bromine is a positive value, we can see that it is in compound B, in compound D, and in compound E. So we can determine that bromine is positive in oxidation state when bonded to more electronegative elements. And that's all there is to this problem.